All right, so today we're going to be talking about radical expressions. A radical expression is just an expression with a radical sign. Which is that sign there, and we take square roots, right? And then the radicand is what we call the expression under the radical sign. So in order to be in simplest form, that means that there can be no perfect squares in the radicand, other than one, no fractions in the radicand, and no square roots in the denominator. So for example, here I've got the square root of 2 over 50. Well, neither of those is a perfect square, but I notice that that's a fraction I can reduce, right? You guys agree I can reduce that? Mm-hmm. Yes, I can just divide them both by 2. And then I have the square root of 1 over the square root of 25. And it's okay to separate it like that into two radicals if that helps you see it easier. So what is the square root of 1? 1. And the square root of 25? 5. And so that would be your answer. 1 over 5. Later on this week, we're going to talk about rationalizing the denominator when you don't have a perfect square down there. But all the problems on your homework tonight should have perfect squares. So if it's a fraction that doesn't have perfect squares, try and reduce it, okay? All right, here's another example. 8 squared, the square root of 8 squared plus 15 squared. So I can't just do 8 plus 15 because it won't come out to 23. The answer is not going to be 23. You have to first simplify what's under there. Treat the radical as a grouping symbol. So we do grouping symbols, exponents, and then so on. So so we're going to take care of our exponents. So 8 squared is 64, and 15 squared is 225. If I add those together, they add up to 289. And the square root of 289 is 17. So see, it didn't equal 23, did it? So you want to be careful with that. Don't think that you can just take the square root separately. When there's a plus or a minus sign, it's just like when we had radical expressions. They're a package deal. They stay together until you get rid of that plus sign, okay? You may run into a problem that has a polynomial. So what you need to do in this case is factor the trinomial. So x squared minus 6x plus 9 is x minus 3 times x minus 3. You can rewrite that, of course, as x minus 3 squared. And whenever you take the square root of something that's squared, what happens? They just go, it undoes it, right? They're opposite operations, so it would just equal x minus 3. Just like on our 5-a-day, right? Okay, and then we learned earlier in the year that we could factor out perfect squares. So what perfect square goes into 24? 4, right? Remember 4, 9, 16, 25, 36, we look for those, right? Okay, so that's the same as the square root of 4 times the square root of 6. I can take the square root of 4, which is 2, so it becomes 2 root 6. Okay? And then when we have variables, like a monomial, here we've got x cubed times y to the 4th. You want to have even numbers, right? So I'm going to rewrite my x cubed as x squared times x. And then the y to the 4th is an even number, so we can take the square root of it. Because remember, it was like we were dividing everything by 2. You guys remember that when we did fractional exponents? So the square root of x squared is just x. the square root of y to the fourth is y squared, and then I leave the x by itself underneath the radical. So any questions on that? All right, so we're going to do a few problems on your whiteboards. So here is your first one. You can rewrite it, right, as a to the fourth times b to the sixth times b, so that we have even numbers, right? So what's the square root of a to the fourth? A squared. Do I have the radical anymore once I take the square root? No, I've done that operation. It goes away, and I just write the a squared. Okay, what's the square root of b to the sixth? What's half of 6? 3. So it's b to the third, and then I still have my 1 leftover b under a radical. Okay? All right, how about let's do this one on your whiteboards. Say it nice and loud, Jamie. What goes into 128? 64. It's 64 times 2. So what's it simplify to? 8 root 2. All right, here's another one for you guys to try. All right, so initially you guys might just see the 4, right? That 48 was 4 times 12. And then we've got a squared times b. So I have 2 times the square root of 12. Well, 12 has a perfect square in it. What goes into 12? 3 and 4. So I'll write 4 first, and then the 3. And then the square root of a squared was a, and then we still had our root b. So now I have 2 times 2 times a, and then we have 3b left under the radical. So it ends up being 4a root 3b. So even if you don't find the biggest perfect square that goes into it, after you've factored it, like where we had 4 times 12, then you need to recognize, oh wait, 12, I can go further because there's a 4 inside the 12, okay? So it's okay if you don't find the biggest one right off the bat, but you need to go looking, all right? Alrighty, how about, let's do this one now. Okay, so we end up with root 9, root 4, root 3 over 5. So what's the square root of 9?
3.
And the square root of 4?
2.
2. And then you just multiply them together, so we get 6 root 3 over 5. All right. I think you guys can do this one too. Give it a shot. Okay, so we have 3 times the square root of x squared times the square root of x times 4. So the square root of x squared is what? What's the square root of x squared? It's just x, right? And then we still have a root x, and then all over 4. All right. Last one for your whiteboards. Square root of 72, x to the 5th, y to the 4th. Okay, so we end up with 3 times 2, x to the 4th, the square root of that is x squared, y to the 4th, we get y squared, and then left under the, so I've used those, right? So left under the radical we have 2x. So if we multiply together everything in the front, we have 6x squared y squared times the square root of 2x. Okay, any questions? Alrighty, that's all I've got for you today.